Right, folks, I'm going to kick things off now. Good evening. Thank you very much from wherever in the world you have joined. I'm assuming the majority of people have joined from Scotland. Welcome, folks, and thank you once again for spending some part of your day with us. My name's Robin Huggins. I am the Client Services Director with a talent acquisition, recruitment and people solutions business called MBN Solutions based out of Glasgow. I specialise in the data space. I am one of the hosts of this thing, which is an amazing joint venture between MBN Solutions and the Data Lab. We've been running now for a number of years. We've got a community of thousands. There's loads of us have made really good friendships through it, and it's a thing I'm incredibly proud of being a part of. This evening, very special guest, Mr. Allan Stevenson of Weights and Biases, joining us. Thank you very much, sir. Alan's going to take us through essentially three parts to the evening, Allan. Number one, a bit of an intro. Number two, you mentioned a little bit more about what the products do, and then a little competition thing.
Yeah, exactly. Yep.
About an hour and a half all in, folks. So there will be breaks throughout. Conscious that this is a bit of a longer session this evening. So we'll have wee breaks, and one of those breaks is going to be the fantastic swag show that everybody's really looking forward to. That is about it from me. The only other bit is just to reiterate what I'd mentioned earlier on for anybody that didn't catch it. Alan's hopefully going to be doing a little bit of a Q&A at the end. If anybody's got any burning questions, if you have got those questions, please look at the bottom. There's a little box called Q&A. Please try and keep your questions into Q&A, because at the end, as I mentioned earlier, it can get a little bit busy, and it's much easier to make sure we don't miss any questions if they're all in the box clearly marked Q&A. I know that somebody will end up putting a question in chat. Alan and I will try and catch you. But if you want to make sure your question's answered, stick it in Q&A. And that is it from me. Alan, sir, are you ready? Are you good to go?
Thank you. I am ready. I am ready.
Brilliant, mate. Good luck with it, fella. And as I say, I'll pop back up if you need me. Cheers. Take care.
Perfect. Thanks,
Cheers,
Rob. So, first of all, I guess, just before I even start, has anyone heard of Weights and Biases? In the chat, has anyone ever used it? Has anyone got any opinions on it? Anyone used something similar to it? Michael has. ML Flow, okay. Yeah, Neptune, Adam, that's similar. So Neptune and ML Flow and Weights and Biases all in a kind of similar space. So I'd be interested, as we go through, I'd be interested in your feedback and let me know your thoughts as we go through it. So just to cover my background briefly. So I've probably been in customer-facing roles for the last decade. Spent quite a long time working in infrastructure and cloud roles until I came to the conclusion a few years ago that all the change in the world has been recently and will continue to be driven by ML and AI. And so I made a hard decision to go back to uni a few years ago now. I did a master's in maths and data science supported by the Data Lab, which was quite a tough gig when you're kind of old enough to be, some of the students' dad, as well as older than some of the lecturers. But it was really a great experience. And then I was also placed at Modular Finance by the good folks at MBN here. And I spent some time working at Modular Finance. And then before joining Weights and Biases, about what month? Probably about 6 months ago now. What's this all about? There's quite a lot to cover. So the goal of this is really to generate curiosity around Weights and Biases, and if you haven't used it, hopefully generate some interest in using it. We have free to use personal accounts, and it's also free for academia. So for lecturers, for students, if you're doing a master's or even an undergrad or a PhD, then you can use it. You can use it for that. It's not a goal that you understand everything, because we're going to have to cover quite a lot of things at some pace. And the idea of doing it this way, I'm going to talk a little bit about the platform, I'm going to talk, and then I'm going to walk you through a Google Colab bit of code, which will run through a classification project, and I'll show you what that looks like in the weights and biases platform. And then the idea is that you've got that to go away with. You can keep the Colab. You'll have that code and how that looks in your weights and biases workspace. So then you can go away in your own time if you're curious and start to just play about and maybe understand a little bit more about weights and biases and what we can offer. And so, as Rob said, it's going to be roughly in thirds. There's roughly half an hour of slides, but I'm going to rattle through them fairly quickly. Then I'll walk through the code, and then I'll talk a little bit about the Kaggle competition and what we need to do. And competition, I think, means a lot of things, all things to all people. So, and we don't expect, we're not expecting, live code from scratch. This is really just a bit of fun. So it's really just going to be about tweaking a few hyperparameters, just trying to optimize the results a little bit, and then submitting it to Kaggle to win the all exciting swag, which I'll show later. So with that in mind, the kind of genesis of the company was if you think about the software development process and that DevOps process on this top section here, then that's quite a well-defined process, and it's been quite well defined for quite a number of years now. And in each bit of the process, all of these companies are all like billion-dollar plus companies. So it's a really mature, well-understood space where the workflow is largely understood. There's different ways you can achieve that, but it's largely understood. But when you think about when you think about machine learning, then at a high level the process is fairly well understood, but the way that people do it is wildly different. I know from my time at Modular when I was working on time series forecasting, just on this piece alone, when you think about experiment tracking, so when you're iterating really quickly, certainly in my case, I ended up with details in so many different places, in logs, in Slack, in Excel, which all makes sense at the time, but further down the line, when you need to pull it back together and maybe share results, then it becomes very quickly like trying to find a piece of hay in a stack of needles, just trying to piece all of their different records together. And so what weights and biases have done, really driving out of a kind of initial engagement at OpenAI, probably going back 5 years now, is create this platform and this set of tools to allow you to perform all of these different things as part of the ML pipeline. Any kind of if there's any questions or thoughts on that, just drop them into the chat. So let's have a look at what that logging might look like for different people. So you might make some logs on spreadsheets. Let me see, that didn't move on. Then you might get more advanced and start to log things in a spreadsheet where you can kind of track all these different experiments and the different metrics. Some people might use TensorBoard, and they're all valid and useful ways to log things. But when the team starts to expand, when it's no longer you and there's other people in the team and you have to share results, and then it starts to get a bit harder, and there starts to be more and more things kind of floating around, for want of a better term. And you can see how that starts to become ever more complicated as the number of team members, projects, experiments, and everything grows. And so suddenly you've got this situation where there's, you know, lots of different information, and then it might be, you know, especially in a corporate environment, you might start sending Jupyter notebooks flying around. There might be emails. You might be posting in Confluence, posting things in PowerPoint, screenshots, and Teams and Slack. And eventually, it depends on your pain tolerance, but it gets to a point where you think, maybe there's a better way to help us organize this. Maybe there's a better way to log all of this information. And so, what we've tried to build at Weights and Biases is a system of record for all machine learning workflows. And we tried to think about it through this lens of what are the principles of an ideal ML practitioner flow. And I'd be interested again in the chat, like if you've got any thoughts or opinions. Should there be? I've also looked at DVC. I see Paul. Yeah, so around data versioning predominantly. You know, what do you think of these principles? Do these sound right? Have you got any thoughts? Stick that in the chat. And so to prove to you in real time that you can get started with Weights and Biases, I'm gonna just bring this other screen in here if I can. So all this is doing here is just installing just a blank collab where we're going to install the Weights and Biases library, which probably actually takes the most time. And then using this kind of Jupyter magic here, we just start logging these random metrics to Weights and Biases, and you can actually see these starting to log in real time. So hopefully if you timed me, that was within 60 seconds. And then you can also, as well as it appearing in the Colab or the Jupyter notebook, you can also see that actually within the interface itself, if you want to. So let me. So you really can get started in 60 seconds. But as well as logging all of these metrics, then you can also log rich media. And this kind of speaks to the heritage of Weights and Biases, where like people like Toyota Research Institute was one of the first customers. So there's a big kind of autonomous driving angle here as well. And so we can log these images, and we can add things like segmentation masks. We can log point clouds, audio files, video files, you know, parts of speech for NLP, even HTML files. And so there's a lot of different ways that you can log and record this data, either for auditability, reproducibility, or analysis purposes. And what we also try and do is help you ask questions about your data and models. So like in the tabular world, this is all sort of fairly well established and understood, and that there's different ways you can manipulate numerical data. But what about data that's not tabular? What about images? Because you can't log an image in a data frame. So one of the things we've built is Weights and Biases tables, which allows you to store these different types of rich media within an actual table, and then perform operations on them, so you can sort, filter, or group on any of these different metrics. And I can show an example of that later on if that's of interest. And then also ask questions about training. So how can we easily search the hyperparameter space to figure out, how do we optimize the model, and what's the effect of changing these different hyperparameters? And I'll talk through that as well when I go through the actual Colab document. Then I'll show these charts in real time as well. And so reproducibility as well is really key in terms of that ML workflow. And so what we provide from artifacts is that ability to create this DAG view, this kind of rich data lineage of all the different steps in your process, from that initial raw data through to the evaluation. Because it's, models sometimes, I was just checking the chat. If you have bad predictions or models are behaving perhaps not as you would expect, then it's really important to be able to track back through that lineage and see, oh, for this inference run on model X, I can see that it was trained on dataset Y by X person on this day with this Python environment. And so you can track back and get that kind of rich lineage over time, because we all read the newspapers and see the headlines about how AI is either going to save the world or ruin the world. And so it's important to demonstrate that there's that auditability and control over the process. And then finally, I just want to touch on collaboration. So as we touched on before, you've got this scenario when you've got lots of different metrics stored in lots of different places. Then it becomes really difficult to share results, to write up technical points of view, to write progress reports. And what we can do with reports is create, you can think of reports as like a mashup of a Google Docs type capability and a Jupyter Notebook capability. So we can create this rich canvas where you can write a narrative, you can format different text, and then you can also bring in all of the live results, all of the results from your projects, and display them in a number of different charts and configure that as you want. And then you can share that with either technical stakeholders if they're technical reports, or business stakeholders if you're if it's a higher level, or maybe you're just demonstrating progress. And so I'm just going to bring in like some examples here just to touch on these, and then we'll get into the Colab. So I mentioned OpenAI. They were one of the first customers. In fact, they were the first customer of Weights and Biases, and they used use Weights and Biases reports as their primary means of sharing results with a team and communicating different results. So you can see that we also have, some people use this almost like an archive paper, like an academic report. And the difference here is that you can actually include these live results, and you can start to marry the results with the text. So it's a much more immersive experience. And then you can also have things like dashboards where you just want to show high-level numbers. Maybe it's to just demonstrate team progress. So there's a huge variety of different things you can do with reports. Like here, for example, this is from an autonomous driving project. So you can see here different segmentation maps. So we can see the raw images here, and then you can see the segmentation masks and how that model's doing over time compared to the ground truth. So a lot of different capabilities I just wanted to just kind of briefly highlight. And then finally, before I move on to the collab, a variety of different links where you can find out more about weights and biases, watch some of the YouTube videos, read some of the reports on Fully Connected. And if you use weights and biases, please do get in touch with me. I'm really interested to hear both your thoughts and the use cases. And with that, I'm going to ask for if there's any questions or any thoughts on that while I post this collab link into the chat, which you should be able to bring up and connect. If I click on connect there, you should be able to bring that up and start to install the weights and biases library and scikit-learn. So I'm just going to pause for a second and let me know if you've had any success. Adam, it's asking me to request access. Interesting. Let me do it this way. So let me post that into the chat. I think that should work, and then you can save it in your own Google Drive, or you'll be able to make your own changes but not edit my version. Cool. Thanks, Adam. Anyone else? Is that successful? Cool, Cynthia, Paul. I see a few new people have just joined as well. So for those of you that have just joined, could you please? So what I've done, I've given a brief overview of weights and biases. Excuse me. I'm now going to walk through this instrumented collab, which is a classification example, and then I'll show how that looks within the weights and biases workspace. I'll probably do that for maybe 20 minutes or so, and then we'll run the competition, which is in Kaggle. So if you've just joined, let me go back to the links, and you haven't signed up for weights and biases, please do sign up on that link, and please also sign up to Kaggle. In the meantime, let me copy this. You should be able to bring up this collab that I've just pasted into the chat, and then connect, and then you can just follow along with me as we go along. So with that, let me execute this next cell. And I'm not going to go into huge or maybe even any detail about what the actual code is. I think you can do that in your own time if you want to. This is really about using this as a means to kind of illustrate how to log things and what it looks like within the weights and biases workspace. So I'm going to log in to weights and biases. I think my key will already be cached here, but you might see an option whereby you have to log into weights and biases and copy your API key and paste it in. But that should be fairly well signposted as you do that, so that shouldn't be too challenging. And then here we're just going to define a function to help us log some metrics and then set some constants. And then I'm going to download the actual data for this project. So what this is doing is it's a classification project of some beans. So what we're trying to do is predict the type of beans based on the different characteristics that we've got within the data set. So first things first, so this is my first run within weights and biases, and a run is just any bit of kind of discrete Python code that you want to instrument. In this case, I'm creating an artifact. So, and you'll see this syncing run, and then I can actually click on this run, which will take me to the weights and biases, so I can see what's actually happened there. And if I go in here just to show you what's happened, we've got runs, Icy Cosmos 1. By default, in weights and biases, we create these beautifully creative run names, which are largely meaningless apart from this number at the end. You've got the option to add your own run name programmatically at runtime, or you can rename the run within the UI to something that makes more sense for you. And then if I go to artifacts, we can see that we've created this data set. And if I look in files, then I can see that I've got some CSV files here. And what I'm going to do now is then I'm going to read those CSVs. I'm going to use that artifact that I've logged. I'm going to read these CSVs, and I'm going to log this data into a weights and biases table. Everyone, just while that's happening, everyone good so far, managing to get access to the Colab, logging things within weights and biases? Any thoughts, questions, observations? Good stuff, Paul. So now what happens if I start to look at this graph view now? Yeah, Mohammed, if you just follow along, executing in the Colab as with me, and then you should be able to see the same things as well. So it's a fairly small data set, so you won't. If it was bigger, then that upload process is going to take longer. So here in this DAG view, we can see what we've actually done so far. We've each of these squares is a run within weights and biases, and then each of these circles is what we call an artifact. So we can see we've had some code that's uploaded a data set, and then we've split that data set, and then we've recorded that we've logged that as an artifact as well. And so what this code here is doing is logging some tables. And so we can actually go and look at these tables within weights and biases. So if I just drag this so it's bigger, and then let's just make it full screen, so hopefully that's a bit easier to see. Then we can use this to, we can see that we've got, best part of 8,000 different rows here, and we can see all of these different metrics here. One of the things that we can do within weights and biases is, somehow my screen is playing up. So one of the things we can do is actually change the way that we view that data. So for example, we can just change this to a plot, and then we can look at that data visualized based on these dimensions that we specify within here. So you can see here, this looks a bit odd where, a lot of this appears to be, all these values seem to be negative, although they follow roughly the same pattern in terms of perimeter size. There's surely negative area is, maybe not a valid thing. So we can use tools like this, and we can also do things like projections for sort of dimensionality, if it's relevant. So there's a lot of flexibility here and capability within tables that you can leverage to explore your data better. And then what we'll do here is we'll just prepare the data. So we're just going to, every time we kind of recommend that every time you log something, you do one of these runs, which is using run equals 1b.init, that you give it a job type. So the job types help you organize and structure your data, and they're something that you can use to help you if you want to filter, sort, or group data later on. And they're also used within this, if I go back to artifacts and graph view, then these are also the job types here. And if I was to expand or explode this out, and now you can see the job type followed by the run name. So you've got some granularity that you can display by structuring your projects in this way. And now we're going to train a random forest to do this classification. So that's fairly just bog standard in terms of the model, and then we're going to log some of these metrics. We can also do things like rich charting within weights and biases, so we can create confusion matrices, ROC curves, precision recall curves, and I'll show you what that looks like in a second. And then I'll also do some other calculations here, which I'm not going to go into in depth, but just means that you can create some different metrics in terms of displaying per class recall and per class precision scores a little bit easier. And we log all of these as a table, as well as feature importance, and then we're going to save the model itself. So we save this model just by saving it as a pickle file and then logging that as an artifact, and then finally just going to finish that run. So we're calling run.finish. So if I, well, let's finishing up there. If I go back to this being Scotland, then we should start to see, if I click on that run, for example, we start to see these charts fill out, so we can see the feature importance, we can see the confusion matrix, and so on and so forth. Any kind of thoughts, questions at this stage? So what if we could improve on things? So for example, some of those areas had a negative area. So all this is doing is all this is doing is just amending those data sets to fix some of the issues with the data. And then we can then log that again as a clean data set. And this is really just to show you how you can kind of build up that lineage within weights and biases, and how you can use the artifacts and the DAG view to kind of illustrate the different processes. So if I just refresh that graph view, and now you can see we're starting to build up this richer picture where we've now done this cleaning operation run, which has resulted in another version of this data set. So if I split this out, and you can see that, and then we've actually logged this model as well. So now that we've got that clean data set, then we'll quickly run through that prep and train again. So I just run that. So this is just mainly that code that we've just walked through, all run again. And Cynthia, so from an integration point of view, we've got integrations with I think we're into thousands of different repos and frameworks and integrations. So I'd have to check exactly how it would integrate with the example that you give, but we can look at that later as well. So that's now logged as well, and then we just run this submission. So this is what this is doing is then taking that trained model and then getting some predictions, and then we're logging those predictions into a CSV file. So if I go back here and go back and look at artifacts and then graph view, and then you can start to see that we've now created a submission, and this these submission CSVs is what we're going to use for the Kaggle competition as well. So let's keep an eye on time. So we've got 10 to 7. So what we can do now, actually, just to test the functionality, is if you just go to the let me get you the link for the Kaggle competition and post that into the chat. So you should be able to sign up for this competition, and then when you do that, you should be able to see submit predictions. So I'll just pause for a few minutes, see if you're able to do that. And while I'm waiting, if the way to access these submissions, so you'll see within artifacts here, we've got the way that this is organized, we've got types and names. So these are all defined by the person. In this case, we've got baseline submission. So I can actually click on that submission, and I can see that there's a submission CSV file. So what I can do, and what I would suggest everybody does just to test the process, is you can download this submission CSV, and then when you get to the Kaggle competition, you can simply click on submit predictions, and I actually have if I can bring this image in here. So this is I'm logged in with a different account. So I would just go to submit predictions, and then I can upload the submission file there from my downloads, which is this one that's been last downloaded. And then I can just click on make submission. So good work, Adam. So all good so far. In fact, what I'll do now, let's take a couple of minutes break. I will go and get the swag as an incentive, and when I come back in 2 minutes, we'll go through the sweeps functionality and then the competition. And Michael, where submission CSV should be, if you go into here, so Bean Scotland Meetup, and then you go into artifacts, then you should see down the left-hand side here at the bottom, you'll see baseline submission, and you can click on that, and then go to Files, and then you can download it there. The other way to do it would be to click on Artifacts, and then from any of these, go to Graph View, and then you'll see Baseline Submission if you see at the right-hand side here. And these are clickable, so you can click on, or you need to explode. Click on Baseline Submission, and that takes you to the same place. And then you can click on Files and download as well. Thank you, Paul. Hope it was useful. Okay, so let me grab the swag. I'll be back in 1 minute for the competition.
Hiya, folks. I think we had somebody just joining there towards in the last couple of minutes. If you have just joined, I'm going to post a couple of links into the chat if you want to sign up to Weights and Biases and also sign up to Kaggle. I'm sure Alan will pop up with some more. In fact, yeah, there's another link here. If you have just joined, sign up to the links that are in the chat, please. And I'll just try and pop them in properly here. All right, would somebody just join in there, mate? Is it just that last link, the Kaggle link, the data science link that they need?
That link and also the collab, which I'll just post back in the chat here.
I think I'm making a complete horlicks of it, to be honest.
Yeah. So for anyone that's just joined and wants to follow along in terms of the competition, if you load up that collab and then just execute through all of the code until you get to this sweep train function here, then that will pretty much catch you up with where we are. And let's start talking about the competition now. So the swag is this rather swanky Weights and Biases travel mug, which I only got
making woo noises.
very recently, and it's good. It's high quality swag. So all people that post to the competition, post to the Kaggle competition, will share a link at the end, and then you can sign up, input your details, and we'll send that swag out to you. So in terms of sweep, so a sweep within Weights and Biases is a means of searching that hyperparameter space. So what we're going to do here is just create a training function, which is something that the sweep can call. And then we're going to define this sweep here. So this is just, in this case, it's as a dictionary within this collab document, but it can also be a YAML file as well if you want to. And then the way that you do it is you obviously give it a name, and then you set a method of search. So that search method can be either random, it can be a grid search, or it can be a Bayesian search. And then you define the different parameters that you want to search through. So in this case, with a random forest, I've set these examples to be foolish, let's say. So number of estimators, max depth, min sample split, min sample leaf, etc. So the idea being here that I'll illustrate how you do it and show the functionality, but then when we actually when I'm quiet in a few minutes, then you've got the option to decide what parameters you want to set and then run through that search space yourself. And then the way that the code is instrumented is that it will, for each of the sweeps that it runs, it will generate a submission file. So you'll be able to pick the best result and then submit that to the Kaggle competition and see how you get on. So let's define this config. So all I'm doing here is just creating this config and then passing that in to 1B sweep to get a sweep ID. And then once I have a sweep ID, I'm just defining the number of runs. In this case, I'm just doing 5. If I was to do 50, it's going to take 10, 15 minutes to run. So I'm just doing 5 to illustrate it here. And then I'm going to click and execute this, and we'll start to see this sweep kicking off. And so what this is doing is essentially contacting the weights and biases central sweep server. And what it's doing is it's just periodic, it's just handing out sets of hyperparameters for each of the runs. In this case, I've defined it as random. So it's just randomly passing out hyperparameters for 5 runs. And I can go and see how this looks in the UI by going to the sweeps icon here. And I can see that I've created this beans sweep. I can click on it, and then I can start to see these sweeps coming in. And this is a parallel coordinates chart. What I can do actually is, while these sweeps are running, let me bring in a more complete example just to illustrate what this functionality does. So this is a much more involved example from a autonomous vehicle project where there's close to 400 runs, and there's been a number of different sweeps run. And what this parallel coordinates plot allows is for us to visualize the each of these lines as a run, and each of these elements are hyperparameters, and it allows us to quickly see how they interact with respect to some evaluation metric, which in this case is accuracy. So I can hover over each of these lines, and I can see for any given run the different hyperparameters that contributed to the ultimate accuracy. And I'm able to do things like filter. So for example, if I just want to look at the high accuracy results, and I can very quickly see that actually all of the high accuracy results have a low learning rate. So maybe in some future search, I maybe don't want to do too much around learning rate. I maybe fix that and then explore other hyperparameters in a bit more detail. And if I just show as well, the way that this works within the UI is that when you do these filters, when you apply these filters, it affects all of the other views as well. So now in all of these other charts, I'm only viewing these high accuracy runs. And the other way that you can see that is that these eyes down the left-hand side, some of them are open, most of them are closed. So the ones that are closed are not visualized. And so when I toggle this filter off, then you can see all of the other metrics start to come in and show again. Adam, are these sweeps being run on weights and biases servers? So the central agent is passing out the hyperparameters, but the actual execution of the code is happening within the Colab environment. So you could run multiple of these. So you could take that agent command and you could run it in multiple different places. Cool. So, and for some reason this chart has not defaulted to show accuracy. So I'm just going to add accuracy here because we're going to evaluate all of these on the accuracy. So you can see a not surprisingly kind of mediocre result given the parameters in my sweeps. Given that if I go back to here, you know, given that these are not great. So last thing I'll show you, and then we will turn you loose to do this yourself, is if we go back to Bean Scotland Meetup, go back to artifacts, and then graph view, then we should be able to see, if we refresh, you can see now what we can see is there's another run. There's the sweeps run, and there's 5 runs, as you saw. To go back here, here, number of runs equals 5. You can see there's been 5 runs, and there's 5 sweep submissions. So the way to kind of interact with this is twofold. So you can see the individual submissions here, sweep submissions, and then each of these names is the run name and then submission, and you can see the individual files. But what you would actually want to do in order to determine what the best one is kind of twofold. So either you can go to sweeps, click on sweeps, and then you can see the run that's got the highest accuracy, or you can expand this table out to give you the tabular view. And then you could filter, move along here, find accuracy, and then you could sort in descending order. So now you can see that the run that had the highest accuracy was amber sweep, and then you could click on that, and then you could actually see the details associated with that. And then you could click on artifacts, and then you could see sweep submissions, and then it's a case of going to files and then downloading the code. I know that's a lot of clicking around, so hopefully that makes sense. But let's get started and see, just put in the chat if you've got any questions or you want me to go over that again. So just to be clear, what we're saying is in this sweep config, you really want to change these parameter values to something that's more meaningful. So I'll leave it to you to decide, either from your own knowledge or from Googling, pick some parameters that make sense, and then run a greater number of sweeps in order to generate some results. Adam, yeah, so what to do is go in, go to the base project, Bean Scotland Meetup. Then on the left-hand side, you will see sweeps. So click on sweeps, and then click on Bean Sweep, and then that will bring you to this view by default. You may have to do this edit and then just add in that validation accuracy at the end. And then the other way to look at it is you can then see amber sweep is the best, and so you can then click and get to the artifacts from there. So any kind of does that make sense? Is everybody able to do that? Can you start to submit things? Let me go to the Kaggle page and see if anybody's been able to make any submissions. Let me go to the leaderboard. So we've got Mohammed and Adam. Anybody else? Any challenges. Let me know if there's any questions, anything that's not clear. While you guys are doing that, what I'll also just show you here some of the other functionality in terms of like parameter importance. So we can, for each of the parameters in the sweeps, you can also look at how important they are with respect to some accuracy. So in this case, for this other project, we can see that the AlexNet, for example, is by some margin of the highest importance, and it's negatively correlated with respect to accuracy. Let me just refresh this. So anybody else managing to, any questions in terms of the Colab, grabbing the submission file, submitting it to Kaggle? Thoughts, questions, observations? Is it Mohammed and Adam, are you able to are you running sweeps now for like a final submission in order to get the best results? Cool. Cool. Sounds good, Adam. Let me, if there's any thoughts or questions, just stick them in the chat. I think I put I think there's a link. Yeah, I think there's a link here whereby I've done some of the Googling for you, so that might help if you're pressed on time. And then the other thing I would do is once you're set on the parameters is just you know, pick a number that's probably bigger than 5 in order to make sure you get a reasonable representation of the search space. This is a bit when we're waiting. I feel, Rob, you should have like, you know, like an accordion or something where you come on, play a few tunes, you know, while we wait.
Mate, I don't have an accordion, but I do have an acoustic guitar.
You do? I forgot you were a guitar player, yeah.
Yeah, I could do, in fact, we should, mate. We should get some tunes going for the next time. People can sing along and chat if you know the next line.
Just don't ask me to sing, and we're all good.
Mate, I used to always be like, no, I'm not singing. As I've got older, I've just became like, do you know something? I don't care. I'm singing. I'm playing and I'm singing. I've usually had a few ciders when I get into it.
Nice.
How are we doing? Nearly there? Cool. I'm going dark again. Stop talking about guitars now.
Oh, I see Cynthia. Cynthia has jumped into the lead. The other thing to consider is that this leaderboard is, well, not to consider, but just for kind of awareness, is that this is calculated with about 20% of the data. So I ran a similar thing a few weeks ago with some of the data lab students, and the person that won was not the person that was leading on this leaderboard. So don't get complacent, Cynthia. There's still opportunity to be overtaken. How do you retrieve models from the sweep? So the way it's been instrumented, if we go back to this being sweep, and I'll just go back to the start each time because I think that's probably the most logical way. So we'll go to Beans Scotland Meetup, and then artifacts. And then down this left-hand side, each of these, each sweep generates both a submission and an associated model with it. And these alphanumeric bits at the start are the run name, or the run ID, I should say. And the way you can determine the best one is you could go, or one way you could do it is you could go to sweeps, click on bean sweeps, then expand this tabular view out, scroll along to accuracy, and actually I might want to pin this column to the front so it's easier to see, and then I can just sort in descending order. And then I know that then amber sweep is the one that I'm interested in, so I can click on that, which will take me to that actual run. And while I'm here, just talk about some of the other things that we capture. So in terms of reproducibility, for each run, we're going to automatically capture all of these things that are associated with the run. So we'll capture the OS, we'll capture the Python version, we'll capture the Colab link. If this was from GitHub, we'd see the Git repo and we'd see the Git state. And then we'll also capture the hardware that it's run on, as well as artifacts. So each run can take artifacts as an input, and they can also output artifacts. So we'll also track that in the run view, as well as any hyperparameters or metadata, summary metrics that we can pass into that run, typically as a dictionary. And then we'll also capture things like all of these different system metrics out of the box. So we'll capture, in this case, we're not really doing very much, so there's not really anything to monitor. But for, if you imagine a longer process, maybe with GPUs, then it becomes much more useful. And then we'll capture like standard error logs and standard output, all of the different files associated with the run. So that's, includes things like requirements.txt, so we can see the state of the Python environment at the time. So we got all the different packages and all the versions of the packages. So like if you came back to this, it depends on your memory, I guess, but anything from, a day, a week, a month, a year from now, you can always track back. So you know exactly the environment that it was executed in, exactly the hardware, all aspects about that run. So anything you need to demonstrate that what you've created is reproducible, it provides auditability, so all of those things. And then we've got a page that touches on the artifacts. So with regard to your question, you can see that the output artifacts for this run were both a model and a submission. Then you can click on those to get access to those models, and I'll do that in a second. And then I've got this turned on in settings, a code where it logs my actual code, so I can go to session history and I can see the actual code that was executed, as well as the order of the cells. So again, if you need to look into what happened in some training process some time ago, you've got all of this information available to you to see. Cynthia, you are allowed to do more than one submission. I think by default it's something like 20. It's certainly more than one, so you should be able to just go to let me find my page again. So you should be able to just go again to submit predictions, and you should be able to see it says here I've got 4 submissions remaining today, so you should be able to submit another prediction. Cool. And then just to finish off this in terms of artifacts, So I can click on, let's say I click on sweep models, I can see we'll auto version things. So if I'm, in this case, it's not super relevant, but let's say I had a process which was generating effectively the same model and I didn't want to differentiate them, then we'll auto version them. So if it had the same type and the same name, then we'll auto version the model. So you can see that kind of development over time, and you can add things like tags. So you can, so I could click here and add things like tags, like I might want to call this, I might want to call it best, for example. So I can create those tags, or I might want to call it production. So, or add notes. I can also add notes in the UI, as well as programmatically, and I can see how it relates to individual runs. So again, these sweeps are automatically named, but you can rename them to something that's maybe more meaningful if you want to. And then we also provide like an API snippet, so that when you, if you wanted to use this in your code, then you kind of use this model, then we show you the way to use that, so it's always clear to see. And you've got access to the metadata, so I've just logged this within the code. It's just a dictionary that I've passed to the artifact when I've created it. And then I've logged this as a pickle file as well. So, and again, I can see this graph view where I've now built up this kind of rich data lineage that shows all the different aspects that we've run through today, through to this these 5 sweeps. So let's go back to here. Let's see, have we got any more? I see Michael, I think, is a new entrant. Welcome, Michael. We're about 22 minutes past, so let's give it another few minutes, unless anyone's running a 300 sweep job that's going to take 2 hours. Let's give it another few minutes and see if we get any more entries, and then I will show the private leaderboard, which will determine the actual winner. But the good news is that everybody who submits, everyone who submits to the competition will get the fancy swag package. Eunice, I can't find the val CSV file, so that should all be covered within the code. You shouldn't need to find it. I'm not sure. I'm not sure what you mean by like you will see it within Colab. So like the val CSV is here in files, but you shouldn't need to interact with it. So I'm not 100% sure what's happening there. Michael, I couldn't find my best submission, so let's go here. So we go to Bean Scotland Meetup. Let's go to the base version, and then we'll click on sweeps, and then you'll have, in fact, what we can also do, let me show you both ways, but click on Bean Sweep. Now you can see all of these different sweeps. In my case, I've pinned accuracy here. I can either look here and find the best one, or I can expand this out. I know that Amber Sweep 4 is the one that has the best results, so I click on that. That brings me to this base run page, and then within that page I can click on the artifacts and then click on sweep submissions, and now I'm brought to this page where I can go to files and I can download that submission.csv and submit it from there. And I can just click on download, which gives it a random name.csv, and then when you go to Kaggle, then you can just click on upload, and then click on that latest one and submit that. as your entry. Did that make sense? Also, Jacob, I think that should have covered your question. Let me know if anything's not clear. So I see Adam's made 5 entries now. Cynthia's made 3. Mohammed 2, and then Michael 1. I see Jacob in there now, and again the score here is not necessarily representative of what the final score is. So this is to prevent things like overfitting. So there's a holdout data set that you haven't seen that is then evaluated. Let me give it 1 more minute. Let me give it 1 more minute, and then what I'll do in the meantime while we're waiting for that is let me dig out the email address in order to claim your swag prize. I'll paste that into the chat. So what to do is I will, when I finish this in a minute or so, I'll take a screenshot of the leaderboard and I'll send it to our events coordinator. If you send an email to events@1b.com and have your include your name on the leaderboard and mention that it's Data Science Scotland Meetup, then we'll send you back a link, which is basically just a form where you can fill in your name and address and details, and we'll post you out for special effect this rather swanky mug. So with that, I'm going to wait till the clock on my laptop flicks over 1 more minute, and then we will call it a day and cover any kind of last final questions. Anybody got any kind of last thing they're trying to submit that they want to give me? You want me to hang on 10, 20, 30 seconds, or are we all good? I think we're all good. So with that, when we switch to the private leaderboard, Cynthia is the leader. Congratulations, Cynthia. And we can see Mohammed's moved up a couple of spaces as part of that. So thank you very much for your time. It's a lot of information. Hopefully that's been of some use. If you have any questions, if you want to use weights and biases personally or in your workplace, do let me know, allan@1b.com. I hope you enjoy the swag, and thank you very much, Rob, for the opportunity to present to you. And I guess if there's any, I don't see any questions in the Q&A. I think we've addressed them all in chat, but if there are any, let me know.
Thank you very much, sir. Allan, very much appreciated, mate. Thank you. Thanks to everybody who's taking some time out of their evening tonight to come along, to learn, to take part, to participate. it makes a massive difference having a little bit of interactivity within everybody. So thank you, folks. Thanks for giving up your time. Allan, thank you again, sir, for giving up the knowledge, sharing with the community, and bringing everybody a little bit of weights and bias knowledge. It really is really appreciated. So thanks, folks. That's us for another month. Hopefully see you next month. I'm not sure who it's going to be, when it's going to be, but I look forward to it once again. Take care, everybody, and make sure you mail Allan and get your swag and whatnot. Thanks again, mate. Appreciate it.
Thanks, everyone.
Thanks, everybody. Good night. Have a good evening.
Cheers.
Bye-bye.
Bye-bye.